Hello, everyone. My name is Valerie, and I am the Outreach and Engagement Coordinator for Future Energy Systems. Welcome to It's Nice to Meet You, our series that allows you to get to know the researchers behind the amazing work of Future Energy Systems. Today, we're talking to Miles Skinner. Welcome, Miles.
Hey, how's it going?
I am great. You?
I'm doing pretty good.
Awesome. Can you tell us a bit about yourself?
Yeah, so I'm a PhD candidate at the University of Alberta. I'm originally from the United States. I got my degree at University of California, Riverside, and I got my master's degree here in Canada. So yeah, I've been living here for a while and I love it.
Well, we're very happy to have you here in Canada. And what are you studying at the U of A?
I'm getting a degree in mechanical engineering. So I study composite materials like carbon fiber and fiberglass, like the same thing you see in like sports equipment and planes and spaceships.
Oh, that is so cool. And how does that relate to energy research?
Yeah, so energy storage systems, which is what I study, they need to be made out of something, obviously. And composite materials have a lot of advantages. They're really strong. They last a long time. They're resistant to failure, like breaking, and so they offer a lot of advantages. But they're also a really complicated kind of system. They're difficult to work with, and so I study the evolution, what we call the evolution, or how these materials change over the lifetime of use after 10 years or 20 years of use, storing energy that we can then utilize.
Very cool. I mean, we want something that lasts a long time so that we're not constantly having to replace it.
Yeah, definitely.
So I'm guessing if we're talking about long-term storage, we're not talking about things like batteries, which, don't last as long. What kind of energy storage system are you studying?
So I study what's called a flywheel energy storage system. And a flywheel is a technical name for a large, heavy disk. And this thing spins really fast. So it's a big, heavy object that spins really fast. And just like a car on a freeway that's moving really fast has a lot of what we call kinetic energy or energy of motion, spinning disk also has this energy of motion. And so we can store energy in the motion of this object, and then we can recover it later. So like a train comes into a station, right? You slow down the train and you spin the flywheel. And then instead of having to pull electricity out of the electric grid to accelerate the train, you can pull energy out of the flywheel and spin up the train. And so this way we can reduce our energy consumption by storing some energy and then sending it back. And these flywheel systems can last for a really long time, 10 years or 20 years. We're still not really certain. We're trying to figure that out right now.
That sounds like such a cool technology. And why are you doing this work?
So it's really important to study energy storage because future energy systems like renewable energy like wind and solar, these are what we call intermittent. So sometimes it's not windy, sometimes it's not sunny, you might have noticed. And in those times, we still want to use energy. We want electricity to power our homes and heaters and things. And so we want to store energy. And so having good, reliable storage that we can pair with these renewable energy systems is really important. And so batteries are one technology, but they're not ideal for some situations. Flywheels aren't perfect for everything, but in some cases, like for trains, they can be really valuable. And so we need to, use the appropriate technology or the right, solution to solve the right problems. And so I'm just trying to figure out a solution to one problem we need for future use of renewable energies.
And there are so many challenges, but yeah, energy storage, especially here in Edmonton, it is dark most of the winter. And that's when we need so much energy to heat our homes. So finding a way to store that during the sunny daytime so that we can use it during the really chilly nights is so important.
Yeah, definitely. The technical term for this is called load shifting. Load being what we, like society, demands off the grid, like we take electricity off the grid, that's loading the energy grid. So what we do is what we call load shifting. So we try and shift that load from one time to another time so that, when we can generate a lot of power, we might not need a lot of power. So we can shift that load to another time. So yeah, and we
Absolutely.
use energy storage to do that so that we can, we can generate a lot of energy during the day, store it, and then give it back, at night. So
Such a good idea.
yeah.
Amazing. And what has been some of your most exciting or interesting results so far as you've been doing this research?
So we've had a lot of ups and downs this year as I've been doing my research, as you might have noticed. And one thing I've been doing is trying to develop a totally new type of experiment that my research lab has never done before. So I'm designing a piece of equipment, designing all of the sensors, and actually designing the what we call the experimental procedure, the steps that I'm going to take to actually conduct that experiment. And this has been a really challenging but rewarding experience to think about everything from, what kind of materials I need to build the frame out of, like the frame of your car, to like what sensors I need and the electronics and how to actually put that together and collect the data. Like, there's a lot of little details that need to come together like a puzzle, but it's like I'm also building the puzzle pieces. Like I'm making the puzzle pieces and the puzzle at the same time. It's been an exciting and challenging thing. And I've never done it before. And I really like that kind of challenge. So, we just started to collect some data, or I just started to collect some data, and it's looking really nice. And I'm very excited that after like a year of work of doing all this design, it's finally coming together. So
Absolutely. It sounds like your most exciting part has also been your most challenging and also most rewarding. Like
yeah,
it's
as it
so
so often is in research, because we're trying to push the bounds of our understanding of science and technology. And so this is really hard to do, as you might expect. And so researchers really like that challenge. And we find that, really exciting and rewarding when we can take that little step forward and say, I've pushed our understanding of science. It, almost gives you goosebumps sometimes.
ugh, I love talking about it. It's so fun.
Yeah.
That's amazing. And have you always wanted to work in energy research, or is this something that just happened for you?
So I didn't really know I wanted to work in energy research. In my undergrad, when I finished schooling there, I was really excited in composite structures. So things like planes and race cars and boats and things. I was really excited about that. And I wanted to study these composite materials some more. And when I was looking around at possibly going to grad school, I found the University of Alberta, and it's got a fantastic engineering program. And my supervisor was fantastic. And he said, I'm doing this thing with, composite flywheels and energy. And I said, I don't really know what that means, but it sounds cool. So, 6 years later, I'm still here, and I really like it. So I didn't know, but kind of serendipitously, I found this.
That's often so much of our stories is I happened to be in the right place at the right time, and I found a passion for this topic that I maybe didn't even know existed before.
Yeah, totally. Yeah. Yeah. I would never have thought, yeah, energy storage. That's the thing I want to do. But, now I'm here and I'm like, wow, this really is the thing I want to do. So,
Oh, amazing. And we talked about what's been really exciting and really challenging, but what's your favorite part of what you get to do?
I really like, as an engineer, I like getting my hands dirty, really getting in there and, building something and, having big pieces of metal and like, plastics and composites. And it's really exciting to like get your hands dirty, put it together and, see something that you just imagined in your head and wrote down on a piece of paper, and then actually get to see it as an object in space. Like that's really exciting. I love doing that kind of work. And then, as a researcher, I generate a lot of knowledge, which also means I feel like I need to share that knowledge so that I can actually improve and help people, improve society. And so education I've also found to be really exciting. So, doing things like this outreach, but also teaching assistantships and like coordinating with professors and stuff, I find that really cool to like be able to share my knowledge and help students. So, both part of research is really, really exciting for me. And I love that kind of stuff. So,
And we love that you are involved in all of this outreach and working with us. So thank you for all of that.
of course, I'm glad to be here.
Yeah. Last question, I guess. Any advice to members of our audience who are interested in getting into this area, maybe mechanical engineering, energy storage, they want to study this? What should they do?
Yeah, I would say just study science and work hard in math. Like those are the two things. Um, I've had a lot of students say to me, "Oh, you must have been great at math when you're younger." Like I've never been great at math. I've always had to work really hard at it. But it's like so vitally important because science and math are the keys to understanding all of the technology that we need in society. And so, yeah, it can be really hard, really frustrating, in school and like your teacher's telling you to solve for X or whatever. You're like, oh, why do I care? But, one day that solve for X could be, find out how long this car chassis will last, or find out, if you're designing a safety system like a seat belt, someone had to design a seat belt. It's like, how much force will the seat belt apply to a person? And is that still safe, And someone had to figure that out. And we know that it is safe to wear a seatbelt, and it's better than not wearing one. And that was all figured out by math and by, study and through science. So my advice to you is focus on math. Like math is really important. Science is really important. And yeah, as you go through school, just think about how does this talk about the world around us? How does this talk about our society and technology and everything? And that will, stay curious, thinking about your brain, getting working.
Amazing. I love all of that. It's so important to really work hard in school and figure out what it is that interests you and connect it to the bigger picture of how does this impact everybody else.
Yeah.
Well, thank you so much, Miles, for sharing your journey with us. We've had so much fun today.
You're welcome. I've had a lot of fun being here.
Thanks, everybody, for joining us. We'll see you next time on It's Nice to Meet You to meet another researcher from Future Energy Systems. Bye, everybody.
Bye.
Thank you so much for watching Future Energy Systems video. Make sure to subscribe so you don't miss any of our exciting content. Check out the links below to our website and learning page where you can find activities, learning extension, and more. You can also sign up on the website for notifications for future videos and interactive opportunities. There's so much to learn as we explore our energy future.